Today we are going to learn to factor out the greatest common factor of polynomials. Before we get started today, let's start with a little bit of review. First of all, if we have 2 times the quantity w plus 1, that will give us 2 times w plus 2 times 1, which gives us 2w plus 2. For the second one here, you multiply 3x times the quantity x squared minus a 4. And that will give us 3x to the third minus a 12x. For our next problem, we are going to review how to find the greatest common factor of each pair of monomials. Okay, so remember when we did this, we prime factored the 4h squared, so that would give us 2 times 2 times h times h. And then the 6, that would give us 2 times 3 times h. And then we circled what was common between each, and we found that the greatest common factor would be equal to 2h. Okay, now let's begin the lesson. Now I want you to recall that the distributive property states that a times b plus a times c equals a times the quantity b plus c. Now I want you to realize, before we have gone a times b and a times c in order to get this, but the distributive property also allows the other direction, like what is shown here. So we are going to use the distributive property to factor out the greatest common factor of terms in a polynomial. All right, so let's go ahead and show you what we're talking about. Okay, so let's start out with this first one here. Now, if I take this first term in this binomial, and we are going to break it into its prime factors. So it's going to be 2 times x times x. Okay, now taking the other one, notice it's a negative 4. So it's going to be negative 1 times 2 times 2. Now, look to see what's common. Well, it looks like there is a 2 common to both of them. We can pull out a 2, put it right here, and then we're going to identify what's left. Well, in the first term, I see there's an x squared left. And in the second term, there's a negative 2. So we're just going to write that down. So it's going to be x to the second minus 2. And that is the factored form of that binomial. Now, I want to just point out something. Sometimes when you factor those, it can be very helpful to align the common factors up. So go ahead and feel free to do that, especially if it has more than 2 terms. Okay, let's go ahead and take a look at this one. It's 8x cubed, so that means it's going to be 2 times 2 times 2 times x times x times x. For the second term, it's going to be negative 1 times 2 times 2 times x times x. And for the third one, it's going to be negative 1 times 2 times 2 times 2 times 2 times x. Notice for these, I lined them up so it's easier to see that they all have a 2 in common, they all have another 2 in common, and they all have an x in common. Now notice all 3 terms need to have that factor in common. So if we rewrite that, I can see that its greatest common factor is going to be 4x, and what's left inside, in the first term, look what's left up here. There's a 2, there's an x, and an x. So that means it's going to be 2x to the second. Okay, for the second one, it's going to be a negative and an x. So minus x. And for the third one, I have a negative 1, a 2, and a 2. So that means it's going to be negative 4. Okay, let's try one where I have a negative in both terms. Now, in doing that one, we're going to have a negative 1 times a 2 times, and I'm going to move and put the 7 over here, times x. And for the 12, it's going to be negative 1 times 2 times 2 times 3 times x times x. So again, let's see what's common. There's a negative 1 common, there's a 2 common, and there's an x common. So our greatest common factor is going to be negative 2x. And let's see, there's a 7 left, so we're going to put a 7 like that. And down here there is a 2 times a 3 times an x left. So now notice I factored out the negative. So since I factored out the negative, we're going to have a plus 6x. All right, let's take a look at this one here. Now we have 3 terms here. So now the 8 is going to factor down into 2 times 2 times 2 times, and I'm going to have 1, 2, 3, 4 x's. Now the 4x cubed is going to be 2 times 2 times x times x times x. And then the negative 2x squared is going to be negative 1 times 2 times x times x. All right, so let's go ahead and see what we have in common. I have a 2 common to all 3. I have an x common to all 3. And I have a second x common to all 3. Okay, so our greatest common factor is going to be 2x to the second. And we're going to be left with, in the first term, I have a 4x squared. In the second term, I have a 2x. And in the third term, everything factored out except for a negative 1. So I'll put the negative 1 there. All right, for this problem, let's see here. We break it down into its prime factors, so that's going to be 3 times x times x times x. Then I have a 2 times x times x. And for the last term, I have a negative 1 times 2 times a 5. All right. Wait a second. Look over here. Is there anything common here, and here, and here? Well, I have 2 x's, but I don't have a third one, so I don't have an x in common. I have 2 2's, but I don't have a 2 up here, so I don't have a 2 in common between all 3 terms. That means it doesn't have a greatest common factor. So what do? Well, we simply call it prime. It is non-factorable. In this slide, we are getting you ready for some application problems. And some of the application problems that we are going to be doing will require a length and a width in order to find an area. Okay, so how do I go about, if I'm given the area, how do I go about finding the length and the width? Well, what we are going to do is we are going to factor it. For this problem, it says the area of a court for the game of squash is 9x squared plus 6x meters squared. Now, what we are going to do, it says factor this polynomial to find the possible expressions for the dimensions of the squash court. Okay, so let's go ahead and try that. We have 9x squared. Well, that's going to be 3 times 3 times x times x. And the 6x is going to be 2 times 3 times x. So what's common? Well, we have a 3 common, and I have an x common. So my greatest common factor is going to be 3x, leaving me with a 3x plus 2 inside. So our possible dimensions are going to be 3x meters by 3x plus 2 meters. Okay guys, well, that's all there is to this lesson. I will see you in class.